Hello class, today we're going to be reviewing chapter 1, Welcome to Microbiology. Our first famous scientist is going to be Louis Pasteur, and he did the swan neck experiment, and John Needham's came up with the thought and theory that of spontaneous generation that you could take something and boil it and kill all the spores or microorganisms. That heat would just kill everything. Louis Pasteur came along and he did his long neck or swan neck experiment. Sorry, and he put that spontaneous generation theory to rest. He did prove that just boiling could not kill just all micro organisms and spores. Our next scientist is Leeuwenhoek, and he developed a microscope that could magnify up to 300 times what we could see with the naked eye. This is an example of his microscope that he made. Our next scientist we're going to talk about is Semmelweis, and I hope I'm saying his name correctly. He was known as the savior of mothers. He was one of the pioneering fathers of the aseptic technique, and he discovered that when physicians would go to the morgue or they would go from doing an autopsy into these new mothers who were giving birth or just after birth, their infection rates would be much greater because they were not washing their hands through those transfers. So once he discovered that, those death rates from those mothers went down drastically. Our next scientist we're talking about is Tyndall, and he discovered that some microbes in the air must be destroyed by something other than boiling water. Kind of like we talked about earlier, you just cannot boil things and expect all germs and microorganisms, spores, all those things to be destroyed. And on this slide it says heat-resistant microbes, which is another reason we use the autoclave today, also combining efforts with heat and pressure to sterilize. So we took his technique, Tyndall's, with the you just can't have boiling water and certain temperatures. You also have to have other things combining, and hence the autoclave has to have 18 degrees pressure. And some other things other than just heat that we do use to sterilize today, thanks to Tyndall's efforts. Mr. Joseph Lister is who we're going to talk about now. He is an English surgeon, and he introduced the aseptic technique, which we still use in practice today. All of our surgeons scrub in and don't just do the happy birthday song when they wash their hands. They do a meticulous scrub in. And then I talked about also our autoclaving with our tools and instruments and things. These came along with Joseph Lister as well. We're going to talk about emerging and re-emerging diseases now. An emerging disease or illness is a disease that has just appeared for the first time. We did experience all of this in 2020 with COVID-19. A re-emerging disease is a disease that it's been on the decline for several years, maybe even decades, and then it has just started to be on the rise spontaneously again. I give the example of measles down here. Measles was a prominent childhood disease in the 1940s. Down on the bottom left, you can see a child that had the measles in the 40s, and on the right is a child, a more modern day child that also contracted measles. The next thing we're going to talk about is deductive reasoning. This uses general principles to determine a logical conclusion to something. And I love this example that I got from online down here, and it says all mammals have lungs. Dolphins are mammals, and then the conclusion is dolphins have lungs because they are mammals. So this is a great example of deductive reasoning. It also gives kind of some more information over here, but I did love these examples. Inductive reasoning It uses observations to gain a general conclusion. So another example that I got from online down here, the sun has risen every morning throughout history, therefore the sun will rise tomorrow. We don't know that. So this is just things that we have seen, though, that gives us an idea of a great hypothesis in the end. So if I pour blue dye into a clear glass of water, an inductive reasoning would be like the water will turn blue. This is also a great little picture down here that I found from online that has some other information on it. Nomenclature. This is naming chemical formulas. I did find this slide here online that does give us an organic chemistry nomenclature chart. It gives us different examples on here if you guys wanted to look at those. Taxonomy, also known as the classification of alive and non-living organisms. Classification is arranged into a hierarchy. You got your domain, your kingdom, your phylum, your class, your order, your family, your genus, and your species. This is our vertical gene transfer. This is the transfer of genetic material that's given from a parent to their child or offspring. This is an example over here of the vertical gene transfer, what the daughter cells carry and those kind of things. It's kind of gives us a pretty good example of the vertical gene transfer. The horizontal gene transfer is an exchange of genetic material. So it may not be something like where like the horizontal may be genetic stuff from the parent to the child, such as hair color, certain birth effects, things like that. This one is a little bit different. It's genetic material. So over here is a little example of the horizontal gene transfer. The next thing we're going to talk about is the genus. We talked about how you had to name different things a while ago with the chart that I gave some examples of. This example that I have is Escherichia coli, which is also known as E. coli, but the Escherichia is the genus name, and this example, Escherichia would always be capitalized and it's always italicized. I did give some examples on here. They're different ones. They're too small for me to see right now, but the genus, I always remember it as being the first part of the name because of the Bible, Genesis. It is the first book of the Bible, so genus is the first part of the name. Species, this is the last part of the name. It is not capitalized and it is not italicized. The example of the Escherichia coli, this would be the coli. It is not capitalized. It is not italicized. So, what is a pathogen? It's a disease causing agent. It can cause diseases or illnesses, a bacteria, a microorganism, a virus, or just a few of the more common pathogens that we know. And I gave you some examples over here in this picture. So we said a microorganism can be a pathogen. So what is a microorganism? There are several different kinds. Some are beneficial and some are not. Examples of a microorganism include algae and certain types of bacteria. Now, some that are beneficial to us, we have to have certain types of bacteria in our gut to promote our health. But then we can also get the bad bacteria that can also cause us harm. So I just mentioned bacteria, but what is it really? It's one of the first things that ever inhabited the earth, and it's present in almost everything. There are different shaped bacteria that we'll probably get to eventually in microbiology. There's the spear shaped, the rod shaped, and the spiral shaped. They all have different names and meanings, but like I said, bacteria can be a very positive thing. It can also be a very negative thing depending on um, what presence is in. And the last pathogen that we talked about was a virus. And so, what is a virus? We all probably know that without even taking a scientific course. I'm sure we've all had the stomach bug or the stomach virus at some point in time. It's a small infectious agent. Um, Viruses infect all living things at some point in time or another. And an example is the norovirus. And then the herpes viruses, you have the herpes simplex and different other forms of that, but those are all viral. Um, this is actually a picture of a virus. Decomposition, what is it? It's the state of rotting or wasting away. Um, this happens with not just us and our bodies, human bodies, but we see it with fruits and we see it with animals and we see it with many different things. But this is a picture of a stage of decomposition in a human, and again, it is the wasting away or state of rotting. All right, we're going to talk about infectious diseases now. What does this mean? And it is a disease or illness that is caused by microorganisms. Um, an infectious microorganism can include, but is not limited to, bacteria and certain type of viruses, among many other microorganisms. I did give an example of one down here at the very bottom. And what are some examples of an infectious disease? Influenza, we especially see at this time of the year, COVID-19, HIV, tuberculosis, and all these do not have to be transmitted the same way because they're not the same microorganism. HIV is transmitted through blood. Tuberculosis, it's transmitted through droplet. So it comes from our mouth in droplet form. So many different things. The stomach virus, a little stomach bug, SARS, that those come from just viruses and things that get on our hands. I gave a great example down here of the bacteria and things that we can transfer just from each other, and this is how we can get these certain types of infectious diseases. Some of those that I just named, like the SARS and stomach virus, different things like that, influenza, and the number one thing to decrease infectious disease is hand washing. So I know that we can't emphasize that enough, especially in healthcare setting. Non-infectious disease. What does this mean? This is a disease or illness that cannot be transmitted from like person to person. Unlike the infectious disease in kindergarten, we tend to share those quite often. This disease is not transmitted by microorganisms. An example, I've listed a little picture here with different examples, and they are some good ones. Diabetes, COPD, certain types of cancers, different things like that we cannot give to each other by unwashing of hands or coughing in an area without covering our mouth or different things like that. These cannot be transmitted from person to person.